you are going to introduce the keynote.
So, you know better. So, okay, right. Thank you. I didn't know that. So, and tomorrow we have the joint talk with SCAN at the same time as today, and I think that's it, right?
That's it.
Yeah. Well, there is something else, but we are going. I'm going to skip that because we are short on time. So that's just about the tool demo. This is a bonus track that you may have. This is a 3D visualization of the citations to the papers in VISSOFT during the last years. So you can check that, and tomorrow you can. Sorry, this afternoon you can enjoy it in VR if you want. That's it.
Yeah, during the tool demo?
We need to.
Then you can see the papers and.
No, that's, and thank you for letting me know that there were more slides.
Okay, so it is my great pleasure to introduce Yoshiki Ohshima. Oh, Yoshiki. Yeah. Okay. So this is my great pleasure to introduce Yoshiki Ohshima. We are really lucky to have him to give us this keynote talk. Yoshiki received a bachelor degree from the Tokyo Institute of Technology, also a PhD from them. He did an internship at Disney Studios in 2000, worked with Alan Kay's group during several years, co-founded the Crockett Corporation, and has a visiting professor position with the Shizuoka University. So, without further ado, let's thank Yoshiki.
Thank you. Yeah, my name is Yoshiki Ohshima, and yeah, thank you for inviting me to the conference, working conference. And I am not in the software visualization research community, but the many software projects or computing projects I have been working on have high overlap in this area. And my work or projects tends to be visual and interactive and collaborative and light programmable and such. So you will find that. So I'd like to talk about those projects and the ideas behind them, and I'd like to give you some different perspectives on what we do. But first and foremost, I hope you enjoy my talk. I try to be entertaining. Before getting into the main part, I'd like to talk about the tool I'm using to present. And this is called Croquet Greenlight. It's a web-based application, and it's a collaborative 2D canvas, and I can drag and I can zoom in out. And actually, I asked David to help my presentation, so he's in the room, so he can wiggle his cursor. And so you might imagine something like a mirror, but this is a little bit more interesting. For example, I can do this, and David, can you move the window? And while I'm beside him, he can move. And if you try this in mirror, you cannot do this. You move your cursor and wait for 1 second, and then other screen updates. So when I talk about real-time collaboration, this is what I'm talking about. This is what I'm going after. And so as a part of self-introduction, this is my personal web page, and just a little bit about me. So I was a student at Tokyo Institute of Technology, and the college merged with something else, and they changed their name last week. So it's like Institute Science Tokyo or something. I really don't know. And I was studying like compilers and object models. Not yet. So I was sort of stuck, and I was procrastinating. And I started playing with open source programming environment called Squeak. And one of the things I did was to port the virtual machine, Squeak virtual machine, to digital device called sharp ZARs. And this time around, Japanese used to make the best electronics in the world, not anymore. And so that basically got the attention from the Squeak team. And I got the internship at Disney. But so this page looks like an amateurish personal web page, but this web page actually is a collaborative application too. So David, can you scroll the page? And he can scroll. I forgot to do this, so I forgot to go into the presentation. So what's on my screen and what you are seeing is exactly the same thing he's seeing. Actually, any of you can scan the QR code if you want to pop up the phone and scan it. You can actually, everybody can scroll. So somebody grabs the scroll, the person can do it, and once that person releases it, so it's like, yeah, this is another little collaborative application I made. So as I said, I got some attention from the Squeak team, and we did a project called PAX PDA. So this is a paper with John Maloney and Andy Ogden. So this was, I should go like this. This was year 2000. So it's basically 7 years before iPhone came out. So it was early. So around this time, folks at Disney were thinking about the future. And in the future, people would bring their own electric devices to their theme parks. And the Disney folks were thinking that what kind of services, what kind of entertainment could we provide? So they wanted to do basically simulation of the future. And like I said, this high-end PDA, sharp ZARs, and the multimedia-rich environment Squeak, the combination was the best platform to do this experiment. So, so we spent 2 weeks in Florida, Animal Kingdom, and my job was basically take care of the lower level things like hardware and the virtual machine primitives. And this was like 2 a.m. I'm trying to make sure things work. But then in the morning, we solicited park visitors and say, do you want to participate in our experiment? And when they say yes, yeah, we gave them short instructions and we handed the device and just let them use for a day. And so I should go back here. So this was how the device looked. And you can see that you can look up like restaurant menus, merchandise, and the shows, like what showtime, and in the queue line, you can play like Disney themed games, and of course you can look up maps, and also you can take pictures and with this camera. And this part was infrared receiver, so we didn't have GPS. So our theme park had infrared signal transmitters around, and whenever the code is received, we trigger location sensitive content. And it wasn't like a compact HTML like text-based app. This one had to be a Disney quality application. So we even had an animated talking head that speaks in the with voiceover when you go to a particular location. And like I said, Squeak and ZAR's combination made it possible. And yeah, the camera, like it's obvious today, but the camera was the most popular feature. And if you go to a Disney park, they used to have a person like this. His job is to take a picture of a family, and when they go home, they celebrate. But this person is clearly worried about his job. And actually, so Alan Kay, Leo mentioned Alan Kay, so he flew to Florida and tried it out. But yeah, this screen has a little fewer pixels. So there are two important things about the implementation. So this was a Disney project, and the typical for a Disney project, it was designers-driven project. So only John Maloney and myself were the programmers, and we had like 1,000 designers. So we programmers couldn't be the bottleneck. So what John did, we did, was not make mobile theme park guide app. We made authoring tool to make mobile theme park guide app. So designers basically made those beautiful graphics in Photoshop, and they like drag and drop into the authoring tool, and then there's a little gesture you can make to make a hotspot for tap. And then when you tap, it takes you to a different card. So it's like many graphics, like images in the stack, and those are linked by this simple hotspot and gesture, setting destination gesture. So designers made the application. And then because it was running on top of the portable virtual machine, they just copy files onto the JARs and it just worked. So that was pretty cool. We couldn't do this if we were trying to compile things for every little change. And another thing was that Speak, or this application actually had the entire interactive development environment hidden inside. So there were some bugs that occurred only on the special device. So it didn't occur on like Mac or Windows, but when we copied the file, it happened. And to debug those, we didn't have to do much of anything. The interactive debugger popped up. We can inspect values, we can evaluate expressions and what went wrong, and we managed to fix it. So this was also a big helper. And if you think about like an interactive debugger as like a software visualization tool and the exploration tool, we had it on this device, and that was a very powerful idea. So as I said, I also like a history of computing, so I would like to talk about a little bit of history. And I mentioned Alan Kay. So he is one of the biggest thinkers and the visionaries in the computing field. And one of the major things he did was to conceive basically what personal computer is going to be, what's going to be like. So he's also known as the father of personal computer. And so 1968 was the time when a computer occupied the entire floor of the building, or even the entire building was a computer. But he saw the Moore's law happening, and he saw some flat panel display technology happening. So he foresaw that in a decade, 2 decades, enough computing power would fit behind flat panel display. And so he thought about that. And many people actually, but his idea was much, much bigger. Many people thought that Alan's dynamic idea was about the hardware. So when iPad came out, some people said that, oh, iPad fulfilled the dynamic vision or something like that. But actual idea was much, much bigger. So he was thinking about what kind of services this kind of devices will bring. and what kind of changes this kind of computer would bring to the society. So he wanted to basically point that out, and this was a drawing he made. And probably you have seen this before, but don't know if you have noticed. But those two screens are showing the exact same thing, like what David and I'm seeing, I was seeing. So they are playing a multiplayer space war game together. And not only that, they actually made the game, it's an end user programmable. So those two kids created the game by consulting digital online library and sometimes ask the teacher and make the simulation. Okay, gravity simulation is like a 3-line of code, so, and they're playing. So that's the idea he had, and that's the future he wanted. And not only Alan was talking about this, he actually tried to make that real. So the technology wasn't there, but he made the hardware with his colleagues, and he made interactive software, and he actually brought it to junior high school and tried it. And like I said, I got too close to him. So this is me, this is my wife, and this is so anyway, so that's Alan Kay, and I want to mention a few other names. So Douglas Engelbart, around the same time or just a little bit earlier, Douglas Engelbart was doing something like unthinkable this way. So probably you have seen this mother of all demos. And so in 1968, Engelbart and his group demonstrated to 3,000 people like collaborative structure, document editing, and the mouse, and also like video chat, and that kind of stuff. So by the way, of course, mother of all demos, back then it wasn't called mother of all demos. But again, so many people think that Engelbart was the inventor of the mouse, or mouse blade, and maybe video chat. But Engelbart's idea was much bigger. Again, so this was the time when the Cold War was in their heads. So this was the time people were thinking that, everybody may be dead, and maybe that's going to happen next week. That's how they were thinking about the world. So Engelbart was concerned with this, and he wanted to solve those problems, and he thought that the technology and sort of better organization of things, including people, vertical people, should augment human intelligence. And that's the way to solve bigger problems, the problems you cannot solve by yourself. So that's the big idea. The mouse was just a little thing. And the interesting idea here is that, so this is a picture where Doug and his colleagues are using their collaborative system. And one thing to notice here is that they are using their system, so like this is a mouse and Doug has a mouse. They are in the same room and they are using their collaborative system. So today, if you want to work with somebody, collaborate with somebody remote, your get-go software may be Zoom or maybe Google Meet. Are you going to use Google Meet when your collaborator is in the same room? And you don't, because it does not augment your intelligence. This was their day-to-day to augment their planning, and they were using it. So that's something to think about. And by the way, this is my wife and this is Doug. So there are a few more things about the history. And those work, like Alan's and Doug's and others, were funded by the government, US government's funding agency for the upper IPTO. And JCR Rickrider and Bob Taylor were directors of that funding organization. And Rick Ryder wrote this paper, Man-Computer Symbiosis, in 1960. And this was very early, but Rick Ryder was thinking about basically societal change that computer technology would bring very early. And then together in 68, they published a paper titled The Computer as a Communication Device. And this was basically founder summarizing their fundees' work and also providing some visionary directions. And one of the pictures in the paper was like this. So you can see this was influenced by Engelbart's work. But basically, one person is presenting the design of bridge, but some others are maybe checking the material strength, or some others are actually running the simulation and using the computer as an actual tool. So they were thinking about this kind of future. And another thing in the paper was this. So this is a computer agent, and it's named Oliver. That's an inside joke for them. But basically, the agent would be smart enough so that when an insurance salesman comes, the agent would figure it out and say the boss is out. So they were talking about this kind of feature too. So those are the background I sort of got heavily influenced by, and actually Croquet Greenlight is one of those, but many things I'm trying to do are sort of trying to advance those ideas. But one more little thing before showing demos. And when I got invited to this conference, software visualization, those two terms, software and visualization, reminded me of the Arthur Koestler's three domains of creativity idea. And by the way, Arthur Koestler wrote this book, The Ghost in the Machine. And for those who are anime or manga fans, you should know this, because the Ghost in the Shell was influenced by this idea. So it's worth reading. But anyway, but a little annoying thing is that Arthur Koestler was actually sort of anti-Japanese and like anti-Indian and sort of anti-Eastern philosophy. But this idea is still good, so I want to mention it. And what he said was that creation happens when like two ideas come together. And if you try to incrementally improve one idea, like you don't get creation. So let's say, but if the creation, and he sort of characterized the creation in different ways. So if it's like science, it's like two ideas coming together, but you find out like they are superimposed, or actually they are the same thing. It's like electricity and the magnetism. They look different, but when you find out, well, they are the same. So that's like science discovery. And the reaction to that discovery or creation is like, aha, that's the scientific reaction to scientific discovery. And then art is like two ideas coming together. Maybe those are juxtaposed, and one illuminates something in the other. And when that will make you see something you couldn't see before. And then you see something new, and then reaction to that is like, right? And there's one more thing he talked about humor. This is much like quicker reaction. So there are two ideas come together, but they collide, and then your reaction to that is haha. So basically, this making a joke is easy. So this is a fill in the blank. You just bring in two conflicting ideas in one sentence, and you get a good joke. Okay, so that is a joke. Okay, again, so the software visualization, like on the surface, sounds like, oh, science and art. But I think there's a deeper idea. So like the logic of like software or organization of code and the visualization. So those are two ideas. And what like we are trying to do is to find interesting ways to make those ideas come together. So that's how I'm thinking about it. And then I claim actually it's actually great to have humor in it too. It may not have to be like a ha humor, but have sort of have something that gives you like quicker reaction. And my claim is that would make your work much more compelling and easier to get accepted or digested. So thinking about including some quicker reaction, I think is fun. So, okay, so that was that. And I want, yeah, this is really small. I want to show some of this stuff. How am I doing? So, okay. That's not too bad. I want to show some of the stuff I did. So one of those is Squeak eToys. And so this is a web. So originally, Squeak eToys wasn't a web-based thing, but I want to make a point that having like any kind of simulation is a great idea, and it's related to software visualization too, I think. So like simulating, computer can be simulated on computer. That's a powerful idea. And this is a simulation of the Squeak VM created by my colleague Vanessa Freudenberg. And it's running with a Squeak virtual machine on the web. So eToys was with a blocks-based multimedia authoring tool. So this car is following this program, and I can actually break it. Forward bar is outside of it. This ticking means it's going over and over again. I can change the value here and make it go back or such. But another idea here is that there's a viewer, and this one is providing the symbolic view of the program instead. So you notice like X and Y are changing, heading is changing. So basically you have two views on the same program. And not only that, you can manipulate them to write your program. So one thing we used to do often is to like draw a steering wheel, like a Mazda's steering wheel. And you can view inside of this object. And this one has heading too, and if I use the rotation tool, notice the heading is changing. Also, that would give you an idea. Or maybe I can grab this and drop it to the turnby, and now I can drive the car by rotating this tool. So it's basically software visualization, but also you can program it. And one of the things I did was to write particle simulation. So this is, again, the block-based programming system, but it's simulating 2,000 particles. And this one is stepping, so each particle moves a little bit, and when it hits this green ceiling, it gives a little bit of momentum and bounce back. And also the green bar is trying to fall by the gravity law. And I can basically reduce the number of particles from 2,000 to 1,000. And basically the volume is the half. So this is a visualization of the PV called NRT. But I can make it like 500. And one fun thing is that when you try to stick the 2,000 particles into the space for 500, and you get explosion. So yeah, so this is important thing. That's sort of my point. So I didn't start the eToys, of course, that was before I joined the group, but around 2008 or such, I assumed the lead developer role And that got me to do a panel discussion on Kai, for example, with those famous people like Mitch Resnick and Ken Palin and Caitlin Gallagher. And this you may or may not know, but there was a project called One Laptop Per Child, and actually eToys was the only thing kids could use sometimes. So our software was shipped on like 1 million devices or something. And the next thing I want to show is Shadama. And this is sort of the redo of the previous particle system, but this one started when we wanted to have a better science education. And the science is about making invisible visible, like gas molecules, air molecules here, you cannot see. But you don't want to tell students that you have to believe it, you cannot see it, you have to believe it. You want to tell them like convincing evidences and maybe the computer model that they can play and they convince themselves. So we wanted to make like a particle simulation for that kind of purpose. So like one thing I did was like make a vacuum cannon. It shoots out a ping pong ball with a vacuum pump, and you can watch the video later. But then we made a simulation program or simulation environment. So it should maybe start from this. So it's basically this is my programming language, and it's live programmable. But when you save or like hit the command S, I pass it and translate it to GLSL. So, and then GPU on my laptop is running my program. And what this one says is that basically like make 3,000 particles and feel random. So each particle is called a turtle, following the tradition. So a dot is a turtle, and the turtle has an XY and RGBA. So everybody's X gets like different random numbers between 0 and 512. Y gets a random number. And the set color method on everybody is called. And then they compute their RGB based on their location. And there are only 3,000 particles, so it's hard to see. So maybe I can say 30,000, and maybe 300,000, or maybe 3 million. Am I ready to? And then, I don't know if I can do this. Edit the program in the environment and save it, Command S. And now this move, basically loop says, hey, everybody move, and move says everybody X and Y changes by 1. And draw takes X, Y, and RGB, A, and is the draw point. So if I say loop, they move. That's all in the environment, but disperse. So this is a similar program, but now I have a dx and dy too. And basically this field random dir method sets like unit vector, random unit vector for each of the turtles. And this move thing says, basically everybody move dx and dy. And if I say step, they sort of go and disperse. But while it's going on, I can edit code and save. And now this one is changing the y by a constant value at every step. So it's a simulation of gravity, for example. And again, this is running on my GPU. And this one looks like a picture, but it's actually basically 250,000 particles, each colored based on the pixel values. And this one also has the random direction. So if I say step, it does everybody moves to a different direction. But this gives me an idea. So press setup. So instead of moving them based on their dx and dy, what happens if I say R and G? So use the color component to move them. So save and step. So now you can see yellow is faster than black. And what you can do is minus, and save. And so again, all the changes are compiled into GPU, and now you see, and you laugh. So that's sort of my point. This, I don't know why we laugh when we see this, but it's a visualization that a color component can be used as a direction vector too. But you don't get this kind of idea until you see, you see the code and you see the picture, and oh, I can use this here. So, and then it happens, it's satisfying, and you want to do more. So, software visual, again, when I hear the word software visualization, something like this comes to my mind. And, but last several years, I was doing a startup company called Croquet. And the goal was to make a collaborative application, a library to make collaborative applications. And we call it Croquet OS. And some people had an issue that we are calling this an OS, but actually, Weizmann once said that an operating system is software that manages space and time. And we actually do have a strong notion of logical time-based execution in space. I'm going to talk about memory and the other kind of spaces are managed. So we thought that it's okay to call it operating system. And you can actually use this library to make green light and other things. So I sort of encourage you to take a look at this and ask me if you want to make something collaborative. And then just a mundane example here. So this, like I said, this green light is a web-based application. So the good news is that I can embed something like Google Docs. And then, like I said, what's on David's screen is exactly the same as this. So imagine that you are trying to collaborate with somebody to write a paper and over Zoom. And what you do is send a link to Google Docs, and maybe send a links to other web pages, and maybe send a link to some of your past papers. And 5 minutes in, what's going to happen is that you lose all those tabs in 100 of your other tabs. And, oh, where did my Google Docs go? And you started looking for, and that's your main job. So in this environment, I am confident that David's screen has those 2 things. And on the right, there's a Google Docs, and on the left, there's a past document. And I can scroll, it happens there, and I can point here and, hey, David, what do you think of this picture? And he can type stuff in here and say, so this is like I said, a little bit mundane, but powerful idea that you see, what you see is what they see, and you can collaborate better. But one of the things, yeah, okay. Another thing is 3D environment I was working on. So let's say this. So I loaded a 3D space, and it says 2 visitors. So I am moving around. Oh, now, interestingly, David is the white rabbit. He can move. So, and yeah, maybe let's try this. And I can move around and see, this looks like a big factory of drones. And there's a drone flying in circle. And oh, why is it doing this? And we look at this code, and oh, I see, there's a step method. So this method schedules itself 20 milliseconds. Is it visible? I think so. And while scheduling itself, it says rotate by a little bit and forward by a little bit. That's why it's going in circle. And there's another thing. So when I say pointer down, toggle method is invoked and toggle stops. So let's say I click on it, and there's a little no-code feature in it. So I can say duplicate. So the way it's written is when something is duplicated, the initialization happens, and in this case, they stop moving. So I made many of them, and I can even delete the first one. And this gives me an idea. So what if I edit? By the way, this text editor is collaborative, so don't do it, but David can edit. So it was moving 3 centimeters forward. What happens if I say 3 centimeters backwards? And I'm going to hit the Command S, and it goes backwards, and the exact same thing is happening on his computer. Maybe I should do the gather. So this is an idea that code is data modified on one computer, propagated to participants, and the software visualization is about treating code as data. Why would you stop there? We can execute them. So, and I go here, and it's a big factory. And so, there's a garage door. Interesting, something is happening behind it. And I open, and there's a physics simulation. And actually, those items can be moved by tapping. So if David taps on one of those cubes, he's not here. I can take it. Yeah. So I was doing the earlier one, the inward editing, and showed it to my ex-colleague, and his reaction was that, those programmers are opinionated bunch. They have their favorite text editors already, and they are not going to use the gray, dull editor to edit programs. And that was okay. So my idea was to use an existing editor. I messed up. Why doesn't this show other windows? Okay. This is interesting. In theory, but here I can at least do it, I think. And I didn't mean to use Emacs for this way. Sorry. It's a better editor. Full screen doesn't do it. Give me a second. This is here. It's here. No, it's the same word. Sorry about that. So the idea is that actual code is here, and this sort of cascading objects are described in this program. And let's just connect. And in this program, for example, there's a method called random color, and that's why it's getting random color. Those objects are getting like different colors. But let's say David and I are working together, and he's a designer, and he says stuff like, hey, Yoshiki, I don't want to have those random colors, just make them all green. And then I say, okay, return 00, FF00. And this is just a regular text editor. And I save on my disk, and now all objects are green. And I can change. I'm not gonna do the full thing. So actually, this is how I program stuff in the environment. It's not just for tweaking parameters. I can add new kinds of objects. I can add new behaviors. I can modify existing behavior. So this one happens when you tap, like give a jolt and go up. I can edit this to different things. But imagine that you are trying to do this on Unity or something. You make a like one-line change, and you have to ship the binary to your collaborator. And in the worst case, you might have to modify your server to make sure your colleague installed the new binary, it's matched up with the server, and you restart, you walk to the same place, and then see if your one-line change made sense or not. That's just, it's just a bad way to do it. You want to do this kind of stuff, like you stick your hand in the world and modify and see what happens. That's how you want to program. So that's the something actually you can do with Croquet. And so yeah, so those are some stuff I have been doing, and sort of I'm getting to the concluding part. And again, sort of I talked about history and some of the stuff I did, but I want to summarize some ideas here. And there are 8 pictures, and the top row shows the pictures of actual hardware, and the bottom row shows pictures of analogies, what it is like or what it compares to. So the Engelbart saw mainframe computers, like IBM 1407 and those. And he said that a mainframe computer is like a railroad. It's a clunky, you cannot go places you want to go. You have to coordinate with other people or you have to wait for other people, and then only times they assigned to you, you can go places. And what Engelbart said about his computer is that it's like an automobile. With a little bit of training, you can go anywhere you want. You can go anytime you want. So those are like great analogies. And also the Dick Ryder and Taylor mentioned the computer as a communication device. So like PDP-1 might be a communication device. And this is also a great analogy. It sort of frees you from the idea that computer has to be like complicated stuff. And not only that, it's about people. Computer is something for people to use. That's the analogy sort of that evokes. But I still like Alan's idea. Computer is like a book. And as far as the form factor goes, we are mostly using those rectangular things with one screen, and laptop is similar. But the analogy here is a book. So forget about like devices and mechanics. It is medium to transmit your ideas. But not only like it's a medium, it's a dynamic medium. You can change it. And it is a meta medium. So that the way what you write in the book, maybe in the program form, can change the way idea gets transmitted. So it's a meta medium in that sense. So this idea still hasn't been fully realized in my mind. So that's still I want to see some progress. And when I do this line of sort of the explanation, people naturally come to this question. So what's here and what's here? And actually, what's here is kind of easy. Like nowadays, maybe like your desk itself may be your computer. I saw some papers in the past. And your wall may be a computer. And your glasses may be a computer. And you may have something like a little thing at the corner. And if you talk and say, do something, it does something. That's your computer. So basically, computers become invisible. Yeah, that's why I don't have a picture here. But the interesting thing about is the analogy. there is no single right analogy. You can make any different analogies. So yeah, so as far as analogy goes, I looked at many papers and city as a analogy for software and like diagram. So analogy has a strong purpose to think things differently, and the good ones give you more ideas. And unfortunately, I'm not a visionary, and I don't have a good analogy, but I have a bad one. Like I said, oftentimes you tell something to a computer, do this, and something happens. So some people may think that, or like computer is going to be like slaves or like servants. But I don't want that. Partly, of course, I don't like slaves. But yeah, but I had to ask myself, why do I even care if those slaves are computers, not humans? And then, but I realized why. Of course, I don't like a world filled with slaves. But what I don't like more is a world where it's filled with the masters of those slaves. So those masters will delegate their thinking to their slaves, yet they pretend to know or can think. And I think that's going to be really dangerous. So that's the future I don't want to see. So the idea is something like this. So this was like the that picture, I modified it. So there are many big problems we have to solve, and one person cannot solve. And so our computer system should help, but we can have an AI agent as a part of the coding, not a slave, but helpful, helper, and make people work together and solve bigger problems. And this is a sort of crappy picture I sort of made up. But you can imagine, the idea isn't new, of course. Oh, that is, oh no, interesting. Can you try this? So probably you have seen this video before, or I probably should have said audio. This is Tony Stark and Bruce Banner working together in the same room, and with the help from Jarvis. And they actually didn't solve a problem, they made a problem. But the idea, this picture is crappy, and this is a high production value, but in my mind, the idea is the same. And this is the kind of things I want to make. So I'm not going to actually show it, but I have been working on a local AI project funded by Mozilla. And so right now I only have like 2D stuff. My goal is to have like a room-sized thing where people can work together. So that's what I've been doing. And so anyway, that's my talk. So the concluding remark is that yeah, let's work together. Let's make new things together. Let's think about better analogies. And yeah, let's solve big problems together.
Questions or comments, anyone? Please, go ahead.
This looks so much better than Minecraft. Right? But I never played, thank you very much. I never played Minecraft. But as far as I can tell, you just like put blocks, a lot of blocks, and you just manually can put 10,000 blocks and build a replica of Manchester United Stadium or something like that. So how do we make kids to play with this instead of Minecraft? It would really help them as opposed to doing all that manual work.
So the idea, I have a programming bias, and this may not be really helpful, but in my mind, when you say you use a computer, like people should program, to me that's obvious, but anyway, so Minecraft, it's fine, especially making block, shapes with blocks, that's one step. But Minecraft does let you program a little bit and make a shapes by program or add some new behaviors. And so that's actually, I don't mind people doing that. But one key thing is that, and in the mods, but I want, if there is a mod, I want people to think that, oh, there's a mod I can use. Then how do I make mods? And then that should give them idea of how do I make a program that makes mod. So this recursive nature, sort of making them understand there's a much deeper thing. You can go any depth you want. So making them realize that there are more from Minecraft would be a great thing.
Hi, thank you for the talk. It was really nice. I'm thinking about domain experts programming. So you talked about what you did with PDA in the Disney park. So what you explained to me sounded a lot like HyperCard. Did you look at HyperCard? What's the link with HyperCard? And what was your experience with, let's say, the domain experts programming?
Yeah, do I look at HyperCard? Yeah, the short answer is yes. And so Alan, of course, helped HyperCard. And the HyperCard only had one programmer, but there was a programmer number 2 for HyperCard project. That's Ted Kaler. He's a long-time colleague of mine, and I know Bill at least. So, and sure, I didn't actually play with HyperCard when I was younger. I started playing with it when I got older. But sure, definitely there's an idea that HyperCard on the surface, it's easy to get started, and then you can go to a different level and you can open the programming system and go. But HyperCard wasn't available for PAX PDA, of course. It has to be our system. And if you wanted to do like a color talking head, you couldn't do. So the Squeak, it's a full-fledged programming system underneath, so we could do anything as opposed to HyperCard.
Thank you very much. Now to finish, I think we have something.
Yes.
Oh, that's
We have a for you.
yeah, and also Hans to David.
Thank you very much. It was a very interesting talk. Now remember that we have the group photo. Oh, thank you. Now remember that we have the group photo. So we're going to go outside somewhere, someplace nice, I hope. And we take the photo and then we're back to coffee. And the next session starts in half an hour, right? Good.
Similar stuff to that? Collaborative?
No, not the current stuff, but I saw